Up. My name's Jim. A little bit of introduction about me. This is my first OpenStack summit I've ever attended, and somehow I decided I would also give a talk, a technical talk. I'll just kind of skip through some of this. The important stuff is that I work at GoDaddy. I work on the compute team. My boss is sitting right over there. And I have been working with OpenStack for 8 months, working with our hypervisors. So you might be wondering why you want to shape your traffic at all. Maybe you have some security requirements that are given down upon high that you need to do. They say you need to do this no matter what. You want to mitigate people from doing bad things on your network, on your hypervisors, to kind of mitigate impact all around. Just keep unwanted noise off the wire. And you can also protect against future threats based on how you throttle. Has anyone here worked with the traffic controls in Linux at all? All right, good to see. So the way it works, this is kind of a crash course here, is you can shape the packets. This was actually delays packets. You choose a scheduler that will arrange those packets, and then you classify the packets via filters that basically say, if I'm this type of traffic, go to this route for packet scheduling. And you can drop and mark packets as well. So we'll kind of see this in the next slide here. By default, whether you know it or not, all interfaces in Linux get a default scheduler or QDisk. QDisks are the building blocks on which all the traffic controls are built upon, and they can be classful or classless. So a classless QDisk can't contain any filters, so you can't actually do anything meaningful with that. A classful QDisk can contain the same type of scheduler QDisk that you have chosen, and you can also apply filters to classify the traffic through these QDisks, such as HTTP, DNS, or any other type of traffic that you want to work with. So with OpenStack, there is a default option to turn on some traffic options in Nova, and you can shape traffic inbound and outbound. And the mandatory setting that you need to do is you need to provide it the average speed that you want your VMs to operate at. And all these settings that you choose when you turn it on are actually written to the underlying XML files that OpenStack places on your hypervisors. So this is kind of a use case that we had where we had some requirements. We limited to 100 megabit per guest. We wanted to mitigate flood attacks going outbound from our VMs. We wanted to drop all of our IPv6 traffic because we're not using it at all. And we wanted to drop the LLMNR traffic, which is the Windows auto discovery traffic that's just noisy all around. And we also wanted to make sure that there's anti-spoof protection so that people can't do nefarious things. So this here, the top image, is essentially turning on, using Nova, the built-in traffic controls, setting it to 100 megabit, which is 12,500 bytes. So we also set the peak and burst there, but that's really not important because in our testing, the peak and burst didn't work reliably. So once you enable this on a flavor and you spin up a new image, if you look at the hypervisor that the image is on and look at its network interface, the tap device, you will see what's in the bottom image where the very last line, you're policing at a rate of 100 megabits, all the way at the bottom there. Now, the problem with this is that we're policing the traffic. And what that means is it doesn't matter how much traffic you're shoving down, once you hit that limit, everything else is dropped to the floor. That's not really a very user-friendly approach, in my opinion. But as you can see here, I've listed some pros and cons of just turning it on if you need it. It's simple and it works out of the box. And on the downside, you're policing the traffic versus actually shaping it and queuing it and sending everything. So you're not sending out everything should some doomsday scenario occur. And like I mentioned before, peak and burst don't work very well in our testing. And if you have to apply multiple policies, you can't. It's just on or off. And if you change the settings to the flavor, the changes are not applied to all current running instances or guests, so you'd have to start and stop all of them to get those controls turned on. So if we go back here, we basically got 40% of what we needed done. So there has to be a better solution to this. So what we found is QEMU hooks can allow you to basically write scripts that will parse your XML file that libvirt has. And with that, you can write it in Bash or Python, whatever language you're familiar with most. And you can parse the container's information for whatever you want to pull out of it, so that the hook script will do all the necessary work to actually create filters that we want to apply to those QDisks I mentioned earlier. And all you have to do is put the script in place, restart libvirt on your hypervisor, and you're good to go. So what that gives you is the flexibility to essentially do whatever you want to do. You can do, if you want to just rate limit certain types of traffic, you can. You can have multiple rule sets and policies in place. And I put, as a con to this whole thing, that it's kind of complexity and lots of overhead in writing your scripts, maintaining them, and everything like that. But overall, it's pretty easy. So with the hooks in place, you're able to meet all the criteria that we needed. So we're able to limit all the guests to 100 megabit inbound and outbound. We mitigate packet floods. We drop the IPv6 traffic and the Windows Discovery Protocol packet and get all the anti-spoof. So the way it works here is, to shape traffic, you actually need to have the device on the system that's doing the shaping, and because the guest is not actually doing the shaping, the hypervisor does the shaping, you need to create a intermediary functional block device, which is a kind of a dummy device where you can forward all the VM traffic through, in and out, so that the traffic can be shaped. So if you look at the middle photo, it's a diagram showing that you basically have your QDisk allowing 100 megabit with no special rules or anything, so everything goes through. If you shove 101 megabits through your guest, it will limit all those packets until it catches up, and everything will eventually be sent. And then the picture on the right is with kind of a fast lane, slow lane. So if you hit our filter and we deem that you're doing like a SYN flood or whatever from the guest host, you'll actually get the slow lane traffic, and it'll limit to 500 K a second. So as far as anti-spoofing works, it works out of the box on Kilo, and I believe it's still going to be functional on Liberty. And these are just the ways that we tested how to make sure that everything works. We spun up a bunch of VMs after we turned on all the policies with the hooks. We used iPerf to send data between a bunch of VMs across our staging hypervisors. When the filters were correct, we'd only see 100 megabit. If the filters were not correct, what would actually happen was we would DDoS our own instances in our environment. So it would actually knock the box offline. We also tried to do the SYN flooding to make sure that we're catching those packets and they were getting the slow lane. We would know they were in the slow lane if the packets on the receiving end were only, on the sending end, we'd monitor how fast the packets were going, and we'd see about 500 K a second on those packets. We also went ahead and tried to steal the IPs between the boxes just by IF upping an interface with the IP of another host, and that didn't work. And we also tried to ARP spoof by using a ARP poisoning tool that I found online, and that did not work as well, so that's good. And there's room to improve this whole thing. We noticed that the initial ACK TCP window thing when you're ramping up actually gets the slow lane traffic. So your initial connections to hosts might be a little slow over time. And also all our DNS traffic is actually getting in the slow lane, so that might hinder some performance. So we're iterating on improving that as we keep using the scripts. And the scripts that we're currently using are actually on the GoDaddy GitHub. So if you want to take a look at how it works, the credit on where we found the inspiration to use it is also in that repo. And then I also have links to basically all the other things that I talked about, like traffic controls and hooks and everything else. So if you have any questions on anything, I kind of rambled on a bunch. Just see me. I'll probably stand out back for a while. Thank you.